Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. Let's say that you are naming an imaginary place in your game. And let's say that your game is set in a setting that you want to evoke Finland. But you don't speak Finnish, you just sort of like the culture, or you're making a game that's sort of inspired by the mythology or something, and you want to come up with a name for a city. And let's say that you could just get a map of Finland or an atlas or something, or look online and just pick a little village and just copy the name, of course. But let's say that you don't want to do that. Let's say that you want an original name. Well, you might look at something like this. This is just a list of the 100 biggest cities and towns in Finland. And if you're an English speaker like me, you'd probably notice a few things. You'd probably notice there's more K's and V's beginning words than happen in English. You probably notice there's some A's with umlauts fairly commonly. You might notice that there's a lot more double letters. This one, for example, has a double A and then a double umlauted A as well. You might also notice a double umlauted A there as well. You might notice that some of those double letters aren't ones that appear in English. So we have two U's, one after the other, which never appears in English, partly because the letter W was invented to sort of be a W. We have here a double K, which is another thing that doesn't happen in English. So noticing all these things, you might go, all right, well, I'll make up a word that sort of has those characteristics, and that will sort of vaguely evoke Finland. But you also might think, well, I wonder if there's a way to sort of automate that process, or to do it sort of formally and mathematically in a way that removes my biases and removes things that I might not notice, or conventions of English that I might accidentally put in there. Well, yes, there is, of course, and I've made a program that does that, and that's what I'm going to talk about in this video. So before we get into the code, I'll show you the pseudo-Finnish name that this came up with. Kikkarini, it's called. And to a Finnish person, that probably doesn't sound very Finnish at all, but to me, it got a couple of the things that I noticed about these names. It has a lot of K's. It has these double letters, the double I at the end. It doesn't have the umlauted A's. But it sort of sounds like it could be in this list, at least to me. So let's have a look at the code. All right, so let's zoom in first. Oh, that's probably a little bit. Oh, no. Sorry. There we go. Okay, so the first thing we have is just where I got the data from that I'm using. And we're going to use this dot length. I have used this before. I have referred to this before in previous videos, but this uses this idea extensively. And so I put this here just to remind me how it works. Dot length, you can put a variable and then dot length, and it'll give you a numeric value. And the variable can also be a slot in an array, something like oops, as long as you format it properly, something like that, for example. That would just give you a number based on the 10th slot or slot number 10 of the array Z. And it can be, or you can refer to an array as a whole. So if $Z was an array, that would be valid, just as it would be valid if $Z were a string. And as it says here, for an array, dot length is the highest filled in slot plus 1, And for a string, .length is the number of characters. So for example, we've got this string here, which is Helsinki, and that's got 1, 2, 3, 4, 5, 6, 7, 8 letters. So if we put that at any point, that will be 8. That will return a value of 8. And that can be quite useful to be able to do that, because it allows you to add stuff to the next slot in an array without having to keep track of which slot that next slot is, and it allows you to go through all the letters of a word. It allows you to go through all of the elements in an array without having to have any variable that tells you how high you need to go. So what we're going to do is we're going to turn, we have $E, that's our data, and we're going to turn all this data into sets of 2 characters. So for example, sets of 2 consecutive characters specifically. So for example, with this Oulu, I'm guessing about the pronunciation, by the way, so they'll probably all be wrong. We're going to have one slot in an array, and the array's array $N. We have one slot that's OU, and then another slot that's UL, and then another slot that's LU, and then at the end we have the last letter, which is U in this case, and then we have an asterisk, and that asterisk we're using to indicate the end of the word. You can use any character to indicate the end of the word as long as it's not a character that appears in the data. So out of that particular slot in the array, we're going to create 4 slots in N, and that's true of all of these. So for Helsinki, which has 8 letters, we're going to create 8 slots in N. So it'll be HE, EL, LS, SI, IN, NK, KI, and then I asterisk. And once we've done that, we don't look at E anymore. We sort of cut up the data, we reduce it to its component parts, and then we deal with the component parts entirely. So we have $N. $N is set up with just that null that I put in there, so I don't have to work with slot 0. And that's going to have all of the sets of 2 characters derived from E. And here's how we do that. We have a for loop for $Z equals 1, semicolon space, $Z is less than or equal to $E.length minus 1. So here's our first use of that .length, and then $Z plus plus. So $E.length minus 1. Well, we know that E is an array. So for an array, .length is the highest filled in slot plus 1. So we're going to look, Z is going to go up to the highest filled in slot plus 1 minus 1. And of course, that means the highest filled in slot. So we're going from 1 to the highest filled in slot. In other words, we're going through each slot of E. And then for Y, we have for Y equals 0, Y is less than or equal to $E square bracket $Z n square bracket .length minus 2 $Y plus plus. So there's another .length, and this time we're using the zth slot of the E array. And that's going to be a string, and we know that for a string, .length is the number of characters. So let's say we have 4 characters, so as we do in, say, that one, OULU, then in that particular case, Y is going to go from 0 to 2. So we're going to look at 0, 1, and 2, which means because the first character in a string is considered character number 0, we're going to look at O, U, and L. We won't look at U, and you'll see why in a second. So then we set $N square bracket $N dot length, n square bracket, equals, and there's some quite long code there. So let's deal with each of the 2 sides separately. So $N square bracket $N dot length, n square bracket. Well, we know that n is an array, and we know that For an array, .length is the highest filled in slot plus 1. So this $n.length is going to give us the one more than the highest filled in slot. So if n has got 10 slots filled in, not counting 0, as in if it's filled up to slot number 10, then n.length is going to be 11. And this is quite convenient because $n square bracket $n.length n square bracket is just the next empty slot. It's the next slot we want to fill in. If n has filled in up to 10, well, naturally the next one we want to fill in is 11. So doing this .length allows us to do that without having to keep track of n or have a separate variable. So all this is doing is saying fill in the next slot in n with this thing. And this is quite complicated. We have $e square bracket $z n square bracket $y n square bracket. Now, that might look a bit strange because we've got two dimensions there of e, as if e were a two-dimensional array, but we know that e is only a one-dimensional array. So what's the other dimension? Well, the way it works is e square bracket z, or $e square bracket $z n square bracket is a string, and if you have a string and then a square bracket and a number, that's telling you to look at a particular character in that string. So $e, $z, $y is character number y. Go to the array e. When you're in the array e, go to slot z, and when you're in slot z, go to character y. And then we have $z, $z, y plus 1, which of course just means, well, it's the same thing as that, except it's the character to the right. So this would, at the very beginning, when z is 1 and y is 0, it would put into the n array, it would put E1, 0 plus E1, 2. So that would be just the character H and the character E. When you go plus and it's two strings rather than two numbers, it doesn't sort of add their values together. It just means this character followed by this character. So all of this is just going to mean HE. Put in the relevant slot of the n array a string, and the string is HE. And then we keep, and then because we're incrementing y, next time it'll be EL, and then it'll be LS, and so on. And when we've gone through all of those pairs, then we set that same thing again, n square bracket $n dot length, n square bracket, so in other words, just the next available slot of n. Then we set this thing plus an asterisk. And again, we have $e square bracket z n square bracket. Okay, so it's going to be some, it looks like it's going to be some character in slot z of array e, and the number of that character is going to be $e square bracket $z n square bracket dot length minus 1. And we know that for a string, dot length is the number of characters. So the number of this, the number of the character is going to be the number of characters in the word minus 1. So for example, Helsinki has 8 characters. And so this particular line is going to look at character 7. But remember that the characters start from 0, not 1. So character 7 is this one, it's I. It's the last character. And this is always going to be the case. This is always going to be set the last character plus an asterisk into the relevant slot of n. So these two commands together, this one sets all the pairs. So in Helsinki, HE, EL, LS, etc. And this one deals with the very last character. And then in n set a string which is I asterisk. And that asterisk means the end of the word. So once we've done all that, once we've set it up, we start with Z. Z is going to be the string that we're creating. And it's $E random, and then that's between 1 and $E.length minus 1. And E is an array, so for an array, .length is the highest filled array, plus 1. So E.length minus 1 is the highest filled array plus 1 minus 1, in other words, the highest filled array. So this just is a random number from 1 to whatever the highest filled in slot in E is. And you can see how .length is quite useful here. We can use this sort of format to pick a random slot from an array, and it will always be between 1 and however high we want it to go, and no higher and no lower, but we don't need any number to take care of it. So Z is going to be, to start with, it's just going to be a random word or name or whatever picked from here. But then we say set $Z equals $Z square bracket 0 end square bracket plus $Z square bracket 1 end square bracket. So in other words, the first character and the second character. So these two commands together mean pick one of these in random. So let's say that one, we pick that one, and then just reduce that to just the first two characters, NA. And so that's what we might start with. We'd start with NA. And then, now we've finally set everything up, and we go to add to word, which is the only other page in this program. So Z is the current word, which is not yet complete. This is just a reminder to myself. $Z square bracket $Z.length minus 1 is the last letter of the current word. And what we're trying to do is match the last letter of the current word to the first letter of a randomly chosen element in N, remembering that N is all the sets of 2 characters that we can get from these words. So we started with HE, and now we're going to try and find E anything. So we could find this ES that will be somewhere in the N array. We could find this EU. We could find this E asterisk, because we know there's going to be a end of could be any of those. I mean, there's lots of E's. I won't go through all of the examples, but and so what we do is we set X to be a random. We've discussed this before. This format just gives us pick a random slot from N out of all the ones that are filled in. Now we ask, does X square bracket 0 end square bracket equal $Z square bracket Z.length minus 1? In other words, does the first letter of this pair that we've picked, is that the same as the last letter of Z, the word that we're creating? Well, usually it won't be, of course. And so usually if it is, we'll do all this code, but usually, of course, it won't be, because there are lots and lots of letters. It'll usually be another one. So usually we'll go down to else, and else just says go to add to word, and this is add to word. So this is saying if the two don't match, which they usually won't, just try again. Keep trying until you get until you get the match. So eventually we will get the match. We will have HE, and then we'll have matched that with ES or something. So what do? Well, we set Z equals Z plus $X square bracket 1 end square bracket. In other words, find the right-hand character in this new pair and add it to the end of Z, because that plus, because we're dealing with strings, doesn't mean add them together exactly. It means put it on the end. So in other words, we add a new letter or a new character to this word that we've made. And then we ask whether the new character that we've put on is an asterisk. If it is, well, that's the end of the word. And then we do something else. But usually it won't be. usually we'll go to this code, which says go to add to word. In other words, it's the same as this. It's just saying go to the top of the page. You've added a letter. Great, we haven't finished yet. Keep going. So in other words, it's going to keep going until it matches with a letter that's the last letter of that was the last letter of one of the elements in E. And then it'll say, oh, well, that indicates the end of the word, so I'll stop. So let's say that it does equal an asterisk. Well, we don't want that asterisk. The asterisk is just a sort of command thing. It's not something we want to print out. So we use .replace. So we set $z equals $z dot replace, R-E-P-L-A-C-E, bracket, quote, asterisk, quote, comma, quote, quote, end bracket. All that means is find every instance of the string which is just an asterisk, or sorry, find the first instance of a string which is just an asterisk, and replace it with nothing. In other words, just delete it. So this is just saying if there should be an asterisk in there, find the first asterisk and get rid of it. Then set z equal to, or set $z equal to $z dot to upper first. So T-O, capital U, P-P-E-R, capital F-I-R-S-T, bracket, end bracket. And you do have to do all that formatting, unfortunately. You can't skip the brackets, and I don't think you can make these lowercase either. And all that does, all to upper first bracket bracket does, or bracket end bracket does, is it makes the first letter a capital, because in this case we're dealing with place names, and so we want to capitalize the first one. And we don't, why don't we just capitalize them, oops, excuse me, why don't we just capitalize them in here? Well, because we want this, let's say we want this T in tempere to match with this T in Jakobstad, or whatever this is called. So if we had it like this, well, it wouldn't match. That would be capital T, and the other one would be lowercase t, and it would treat it as two different things. So that's why we got rid of all the capital letters in this set of data. But having done that, we have to add it back when we're finished, and then finally, of course, we print z because we want to get an actual result. And that is how you create, well, in this case, a pseudo finish word. But of course, all you need to do is get a large set of other data, and it can be something else. It can be something that sounds like the name of a Babylonian monarch, or something that, you know, sounds like the name of a whatever, an African, tribal grouping or something like that. Whatever it is that we're trying to sort of vaguely evoke, you put it in the data, and it'll come up with something that's based on the probabilities of one letter following another, or one character following another, because in this case, umlauted A is separate to plain A. They're treated as two completely different letters for the purposes of this. It'll obey the sort of probabilities of one letter following another, but it won't be copied off any one particular word. It'll just be sort of vaguely like, usually, if you're lucky, it'll just be vaguely like the data that we've got. So what I would like to do in future videos, this isn't, there's several problems with this, not least of which is that it's very, very slow. I did briefly say that when you're trying to match two pairs of words, most of the time they won't match, but that has a big effect. It actually makes the program very, very slow, and you wouldn't want to do this if, for example, you were trying to name 500 planets or something like that. If you had a science fiction game and you wanted to name 500 planets, it would be painfully slow to do this 500 times. So what I would like to do in a future video is explore initially a way to do this faster, and then a way to sort of get better results as well. But I hope that what I did today was useful or interesting to at least some of you, and I hope you will tune in next time.